I'm going to start my presentation. This is presentation outline, introduction, objectives, design of the antenna, simulation and optimization, experimental results, result analysis, conclusion, and last of all the references. This is the introduction. Now I'm going to describe the introduction part of this presentation. Microstrip antenna is largely used for its simplicity, fabrication, compatibility with the printed circuit in the microwave frequency region in current wireless technology in such cases mobile communication systems, global positioning system (GPS), microwave sensors. The microstrip patch antenna is essential component. When compared to the conventional antennas, the study of the microstrip patch antennas has made significant progress in the recent years. This research offers a novel design for the microstrip patch antenna bandwidth, augmentation, efficiency, and reduction of the VSWR using a slotted patch adjacent to the radiating patch. A microstrip slotted patch antenna is also proposed for wireless applications in this study. The resonance frequencies of the 8 bands are 2.8 gigahertz, 5.05 gigahertz, 5.8 gigahertz, 8.5 gigahertz, 9.5 gigahertz, 10.9 gigahertz, 12.8 gigahertz, and 13.5 gigahertz with a reflected power of minus 16.3 dB, minus 14.9 dB, minus 16.7 dB, minus 14.6 dB, minus 10.9 dB, minus 18.6 dB, minus 11.1 dB, and minus 20.9 dB respectively. The accurate bandwidth is satisfactory and the VSWR is improved, being less than 2. This antenna is designed for ACX and KU band applications, so it can be used for many purposes. Now I'm going to describe about the objectives of this presentation or this research work. To design a novel microstrip antenna for multiband applications using the slotted patch. Second point is to investigate different designing techniques for creating multiband with desired resonant frequency. To optimize antenna performance with the function of various design specifications like shape, material, substrate, patch, ground, and fading. To determine and analyze the simulated results of different performance parameters such as reflection coefficient, VSWR, gain, directivity, and far field regions. Design of the antenna. In this work, microstrip patch antenna is designed and simulated by CST software. Although there are many software, it is convenient and useful to work with CST. All the parameters are optimized, simulating several times to achieve desired result. All the parameters are tuned in a way that gives maximum possible output. Figure 2 shows the simulation of the antenna in CST. Design of the antenna. Figure 1 are given geometrical structure of microstrip patch antenna, and in table 1 the antenna measurements are also given. Here all the parameters are denoted in this table, and these are the values of these parameters. These parameters are very much important for designing an antenna. This is the experimental results, and I'm going to describe the return losses of the designed antenna. The S11 parameters was calculated using the simulation results. The bandwidth is kept within minus 10 dB. The resonating frequencies of these bands are 2.9 GHz, 5.05 GHz, 5.8 GHz, 8.5 GHz, 9.5 GHz, 10.9 GHz, 12.8 GHz, and 13.5 GHz with the return loss of minus 16.3 dB, minus 14.9 dB, minus 16.7 dB, minus 14.6 dB, minus 10.9 dB, minus 18.6 dB, minus 11.1 dB, and minus 20.9 dB respectively. And this is the figure of the solid-state antennas is parameters characteristics. And now I'm going to describe the VSWR of the designing antenna. A measurement of the power that is reflected by the antenna is referred to as the voltage standing wave ratio, which is also known simply as VSWR. The vitality perception of an antenna is symbolized by the VSWR. The VSWR value ought to be a real and positive quantity. As the VSWR number lowers, the antenna's productivity increases. The explicates of how the impedance of the transmission in a network is matched. For VSWR, the bandwidth should be no more than 2 and no less than 1. In a perfect world, it would be 1. For the profound frequencies, the VSWR values are 1.4, and another one is also 1.4, 1.3, 1.5, 1.8, 1.3, 1.8, and 1.2 are obtained as shown in figure 4. This is the figure 4, and this is the graph of VSWR of the design microstrip patch antenna. This is the experimental results of the directivity of designed microstrip antenna for the following 8 bands, and this is the far field directivity of the designed antenna for phi equal to 0. And these two figures are also for far field directivity of the designed antenna at phi equal to 0 and theta equal to 90. Oh, sorry, phi equal to 90 and the theta equal to 90. This is the figure of gain of the proposed antenna and the far field gain of the designed antenna at phi equal to 0. These two figures are also for far field gain at phi equal to 90 and theta equal to 90. And this is the comparison table of the previous work. I made a comparison with 4 previous works. They are the references 25, 26, 27, and 28. For this comparison table, we can say that the designed antenna performance is better than others. This is the applications and area of the microstrip spectrum with frequencies ranging from 2 to 4 GHz is known as the S band according to the IEEE. Thus, at 3 GHz, it crosses the traditional line separating the ultra UHF and SHF bands. The S band is utilized by weather radar, ship radar, air traffic control, and some satellite communications. 5.05 GHz is used for wireless LAN, and 5.8 GHz is frequently used in wireless audio and video systems, Wi-Fi, radio, local area networks, WLAN applications, ISM applications, and WiMAX. In communication engineering, the X-band's frequency range of the roughly 7.0 to 11.2 GHz is relatively arbitrarily fixed. IEEE defines the frequency range for radar engineering as 8 to 12 GHz. Radar and satellite as well as wireless computer networks use the X-band 13.5 GHz, the frequency of the Ku band, which is mainly used for satellite communications. This is the applications for the designed antenna, and this is the application is also for the resonance frequency of the designed antenna. This is the conclusion. This research proposes a design for a multi-band microstrip antenna that operates between 25 GHz and 14 GHz. An inverted F-shaped slot is applied to the patch for creating a multi-band, and also microstrip line is added for feeding. Different parameter optimization is needed for getting better return loss, bandwidth, VSWR gain, and directivity. The proposed antenna simulation results show that it will perform better for the SCX and Ku band applications. A comparison with previous research is shown. and it is very clear that the designed antenna is much better than others. Future research can use a variety of approaches and materials to produce good outcomes. The simulated results demonstrate the proposed antenna could be a good contender for wireless communication system. It can be built in the future to compare the actual results to simulated results. The antenna's limited gain and restricted bandwidth must be considered. These are the references I used for the designing of this antenna. These are also the references, and I use 28 references. Thank you so much for watching this video.